We have the parametric equations x equals cosine 2t and y equals cosine t from 0 to pi, where t goes from 0 to pi. We're supposed to find the derivative of y with respect to x, and we do that by finding dy dt over dx dt. The derivative of the cosine is going to be the minus sine of t. Derivative of cosine 2t is going to be minus 2 sine 2t. We can convert sine 2t into 2 sine t cosine t. We have two negatives, so they cancel. And the signs cancel out, so we're just going to wind up with 1 over 4 cosine t, which we can express as secant t over 4. Now, in order to find the second derivative, we find the derivative of dy dx with respect to t, and then divide that by the derivative of x with respect to t. The derivative of secant t over 4 is going to be 1/4, so we have our constant, 1/4. Derivative of secant is secant tangent. And then we'll divide that by minus 2 sine 2t, just like we did here. And then we can simplify this a little bit, maybe by converting everything to sine and cosine. So we'll make secant t into 1 over cosine, and then tangent into sine over cosine. We still have our 1/4. And then we can write minus 2 sine 2t as minus 2 times 2 sine t cosine t, as we did before. Then we can invert and multiply, so we'll have sine t over 4 cosine square t times 1 over minus 4 sine t cosine t. And the sines will cancel, and we'll be left with a cube of the cosine in the denominator. So we have minus 1, we have a negative, we have 4 times 4, so 16, and then cosine cube t, which can be written as minus secant cube t over 16. So that's going to be the second derivative, and we were examining this derivative on the interval from 0 to pi. Now, if we want to find where this thing is concave up, that's going to happen where the second derivative is positive. So we're just going to take that second derivative and set it greater than 0. And if this is going to be bigger than 0, it's going to happen when the secant cube is less than 0. Well, if the cube of the secant is less than 0, then it must be that the cosine is less than 0. Now, we're only on this interval from 0 to pi here, and the cosine is only negative through that range between pi over 2 and pi. So we are concave up on this interval pi over 2 to pi.